Hello, students. Today we talk about wet dust collectors. It is mainly explained from the following three aspects: dust removal mechanism of wet dust collector, characteristics of wet dust collector, and common wet dust collectors. Wet dust collector is also called washing dust collector. It is through the contact between dusty gas and liquid droplet or liquid film, impact, etc. equipment for separating dust particles from airflow. In the dust collector, when dusty gas collides with water or other liquids, dust particles condense and then trapped by liquid medium achieve the purpose of dust removal. Characteristics of wet dust collector. Advantages: it can purify solid particle pollutants in waste gas. It can also remove gaseous pollutants. At the same time, it can also play the role of gas cooling. Wet dust collector also has less equipment investment. The utility model has the characteristics of simple structure and high purification efficiency. The equipment itself generally has no movable parts, suitable for purifying non-fibrous, and do not react chemically with water, all kinds of dust without bonding phenomenon, especially suitable for purifying high temperature, inflammable, explosive and harmful gases. Disadvantages of wet dust collector: easily corroded by acid and alkaline gases. Pipeline equipment must be anti-corrosive to consume a certain amount of water. Dust recovery is difficult. Sewage and sludge should be treated so that elevation height of smoke is reduced. The chimney will produce condensed water in winter. Encounter hydrophobic dust. Simple use of clear water will reduce dust removal efficiency. It is often necessary to add purifying agent to improve dust removal efficiency. Antifreeze of equipment should be considered in cold areas. Common wet dust collectors are: 1. Gravity spray scrubber, also called spray tower, also called washing tower. The gravity spray dust collector is of hollow tower structure. It is the simplest structure in wet dust collector. In the hollow tower, sprayer with one or vertical row of atomized washing liquid. Dust-containing gas moves upward from the top of the tower. The droplets are ejected from the nozzle and move downward. Due to the inertial collision between dust particles and liquid droplets, interception and condensation, etc. make larger particles trapped by droplets. Gravity spray dust collector. It is widely used to purify dust with particle size larger than 50 microns. The purification efficiency of dust with particle size less than 10 microns is low. It is rarely used to remove gaseous pollutants, usually combined with high-efficiency scrubber. It plays the role of pre-purification, cooling and humidification. This is the schematic diagram of the spray washing dust collector. It can be divided into counterflow type, parallel flow type and cross-flow type. Parameter requirements: water gas velocity ratio 0.015 to 0.075. The inlet velocity of gas is 0.6 to 1.2 meters per second. Water consumption 0.4 to 1.35 liters/m3. Pressure loss less than 250 pascals. Its advantages: simple structure, small resistance and convenient operation. Disadvantages: large amount of water, huge equipment, covers a large area, low dust removal efficiency, applicable to particles above 50 microns. Adjust the specific resistance of electrostatic precipitator particles. Remove harmful gases. 2. Cyclone washing dust collector. Vertical cyclone water mill dust collector. Dust containing gas inlets from the lower part of the cylinder. After entering along the tangent wind direction, rotational ascent. Subject: dust particles to centrifugal force. Throw to the inner wall of the cylinder. It is adhered and trapped by the water film flowing down the inner wall of the cylinder and is discharged from the lower cone dust collector. Parameters: Inlet wind speed 15 to 22 meters per second. Outlet gas velocity below 10 meters per second. Maximum dust concentration 2 grams/m3. The water-gas ratio is 0.4 to half a liter/m3. Efficiency 90% to 95%. The resistance is 500 to 750 pascals. Influencing factors are proportional to the inlet wind speed. Is inversely proportional to the diameter of the cylinder. This is the schematic diagram of the central spray cyclone dust collector. Dust-containing gas is tangentially injected into water from the lower part of the cylinder. Water is sprayed through the installed multi-head nozzle. The water mist ejected radially collides with the spiral rotating airflow, cause the particles to be trapped because the outlet gas, the moisture content, is relatively large. So, generally, there is enough height above the spray section so as to achieve a certain defogging effect. This is the schematic diagram of the central spray dust collector. Horizontal cyclone water film dust collector. Dust containing gas from one end of dust collector enter in the tangential direction. The gas rotates along the spiral channel. Under the action of centrifugal force, dust particles are thrown at the cylinder wall. The airflow impinges on the water surface. Collision between water droplets and dust particles. Capture a part of dust particles. The airflow carrying water droplets continues to rotate. Water droplets are thrown to the wall of the device to form a water film and capture the dust particles falling on the wall of the device. This is the schematic diagram of the horizontal cyclone dust collector. Parameters: the average wind speed of the section is 11 to 17 meters per second. The distance between the water level in the tank and the inner barrel is 100 to 150 millimeters. The dust removal efficiency is 90% to 98%. Water supply 0.06 to 0.15 T/m3. Pressure loss 800 to 1200 pascals. The main influencing factor is the water level in the trough. Passage velocity, intersection wind speed, pressure loss and water consumption. Advantages: simple structure, low equipment cost, reliable operation, high capture efficiency. The efficiency of dust below 0.5 micron is also 95%. Moving distance of airflow in tower, longer than spray tower. The relative velocity of dust particles and droplets is also large, so that efficiency is high. 3. Self-excited spray dust collector. After the self-excited spray dust collector makes the dust-containing airflow enter the dust collector, turn down and hit the water surface. Coarse dust particles rushed into the water and were caught. Fine dust particles that settle in mud hoppers and are not replenished. As the airflow passes through the S-shaped channel at high speed, accumulate a lot of water, make dust fully contact with water droplets through collision and closure, so that gas is further purified. After purification, the gas baffle is dehydrated and emptied. This is the schematic diagram of self-excited spray dust collector. Advantages: compact structure, small footprint, convenient construction, good compound adaptability, low water consumption. Disadvantages: the price is more expensive. High pressure loss. The parameter liquid-gas ratio should be lower than 0.13 liters/m3. 500 to 4000 pascals. The efficiency is between 85% and 95%. This is the schematic diagram of the impingement water dust collector. 4. Venturi dust collector. Venturi dust collector mainly includes atomization, coagulation and defogging process in the contraction tube and throat. The relative velocity between gas and liquid is very large. Droplets ejected from nozzles under the impact of high-speed airflow. Further atomization into finer droplets. At the same time, The gas is completely saturated with water. The gas film attached to the surface of dust particles is broken. Moisturized dust particles. Fierce collision and condensation between dust particles and droplets. The flow velocity in the diffusion tube decreases. Pressure rise. Faster condensation. It is easier to be arrested after cohesion. This is a schematic diagram of Venturi washing dust collector. Its parameters: the inlet velocity of airflow is 16 to 22 meters per second. The gas velocity of throat is 50 to 180 meters per second. The water injection speed is 6 meters per second. Water vapor ratio 0.5 to 1 liter/m3. Pressure loss 1500 to 1800 pascals for 0.55 micron dust. The efficiency is 99%. Influencing factors: relative velocity of water vapor and particle size of dust. Wettability, liquid-gas ratio. Its advantages: small size, simple structure, high efficiency of fine dust. High temperature flue gas cools obviously. No moving parts. Disadvantages: large pressure loss. This is a Venturi dust collector. Calculation formula of pressure loss. That's the end of today's class. Thank you all.